Hello, everybody. In this video, I'm going to go through lesson 4.3, problems with with parallel lines and transversals, or with lines, just lines works too. With lines and transversals. Okay. So, we are going to start with just some examples here. This is not like a note heavy lesson. This is more of an example heavy lesson. So first thing we are going to do is we're going to draw an example diagram. And here we're going to have M and N. Oops. This is M and this is N. And then we have this transversal T. And M and N are two parallel lines. Also something to note. Oh, okay. And we have angles 1, 2, 3, 4, 5, 6, 7, and 8. So we have these 8 angles here. Oops, I don't know why I made it worse. First thing we are going to do is we are going to identify all angles congruent to angle 7. So let's take a moment here to identify angle 7. That is this angle right here. So all of our congruent angles that I can find. 7 is a corresponding, right? If we look at these two different types of intersections, I have the intersection where the transversal meets M and where it intersects T, or sorry, N, right? M and N, and T intersects both of them. So 7 is along line N, and the same angle along line M would be this angle 3. So I know that angle 3 is congruent to angle 7 because they are corresponding angles. So by the corresponding angle postulate, I know those angles are congruent. All right, I also know that 7 is congruent to the angle directly opposite it, right? It's also congruent to 5. Because they are vertical angles, right? Angle 7 is congruent to angle 5 by the vertical angle theorem. All right. And then I also know 7 is an exterior angle. It's on the outside of the parallel line N. And the alternate exterior angle to this angle 1 would be, or sorry, to angle 7 would be angle 1. So 7 is kind of below transversal T outside of the parallel lines, and 1 is above transversal T on the other side. And those two angles are congruent. So angle 1 is congruent to angle 7. These are alternate exterior angles. So those are the main kind of 3 sets of congruent angles here. Part B. If the measure of angle 4 is 5x plus 11 degrees, and the measure of angle 6 is 6x minus 4 degrees, find the measure of angle 2. in degrees. So let's kind of take a moment here. We know the measure of angle 4. So I'm going to kind of get rid of some of this highlighting from before. I know the measure of angle 4 is 5x plus 11 degrees. And then we know the measure of angle 6 is 6x minus 4 degrees. Oops. And our goal is to find the measure of angle 2. So I hope you notice that the two angles we were given, angle 4 and angle 6, are congruent because they are alternate interior angles. Angle 4 and angle 6 are on the inside of those two parallel lines on opposite sides of the transversal. So that means then that they're congruent, and the measure of angle 4 is equal to the measure of angle 6. So now I can kind of solve for what this x is. So that way I can figure out what, in degrees 4 is and what in degrees 6 is, because they're the same. So let's solve. We have 5x plus 11 equal to 6x minus 4. And if I am solving this, I'm trying to get x all by itself. Working smarter, not harder. I would really want to actually move the 5x over to the 6x, because when I move it, I will subtract. So minus 5x minus 5x. And then I will lose it on the left side, right? 5x minus 5x is 0. So then I just have 11 equal to 6x minus 5x is 6 minus 1, or 6 minus 5, excuse me, is 1x. So 11 equals 1x minus 4. And then I can continue to get x all by itself by adding 4 to both sides. So that way our 4s will cancel on the right. And 11 plus 4 is 15, equal to 1x. So x then is 15. So I've solved for x, right? I know in the measure of angle 4 and the measure of angle 6, whichever one I want to look at, x is 15. And our goal is to find this measure of angle 2. And angles 2 and 4 are vertical angles. So they are congruent. So if I know what the measure of angle 4 is, then I know what the measure of angle 2 is. So let's substitute x equals 15 in for the measure of angle 4. And again, I could also do it for the measure of angle 6 since they're congruent. But we know the measure of angle 4 is 5x plus 11 degrees. And we are going to let x equal 15. This was originally x. And now I can multiply. 5 times 15 is 75. Plus 11 gives us 86. So the measure of angle 4 is 86 degrees, which means then, since angles 2 and 4 are congruent, the measure of angle 2 is also 86 degrees. Angle 2 is also 86. All right, next thing we are going to do is going to be given that M is parallel to N, and the measure of angle 3 is 120 degrees. We are going to prove that the measure of angle 8 is 60 degrees. And our drawing here, we have M parallel to N. And then we have this transversal, which in this diagram actually is P. And then our angles are 1, 2, 3, 4, 5, 6, 7, and 8. And make sure you label your angles like I did, otherwise your proof is not going to be quite the same. So it's given that M and N are parallel and that the measure of angle 3 is 120 degrees. And here is angle 3. We want to prove the measure of angle 8 is 60 degrees. So let's set up our 2-column proof. We have our statement and reason. And we always start with what we know or what's given. So the first thing we are going to say is we know that M is parallel to N and the measure of angle 3 is 120 degrees. Maybe I'm going to write it a little bit nicer. Oh, why did it do that? I'm going to write it like that. And this is given. All right, so now that I know that these two lines are parallel and the measure of angle 3 is 120 degrees, where can we go from here? Well, next, I can note that angle 3 has to be congruent to angle 5. And the reason here would be our alternate interior angle theorem. States if you have two parallel lines cut by a transversal, the alternate interior angles are congruent. So we have two parallel lines cut by a transversal. Angle 3 then has to be congruent to angle 5. So where can I go from here then? Well, now I can say that the measure of angle 5 has to be 120 degrees. We know the measure of angle 3 is 120. So by the substitution property of equality, substitution property of equality, angle 5 also is 120 degrees. So I can continue on. I know then the measure of angle 5 is 120 degrees. And our goal is to prove that 8 is 60. They're congruent. 5 is 120. 5 and 8 form a linear pair. They form a straight line. So now I'm going to say the measure of angle 5 plus the measure of angle 8 is equal to 180 degrees. This is our linear pair postulate. And then, using what I know the measure of angle 5, right? Measure of angle 5 is 120 degrees. So 120 degrees plus whatever the measure of angle 8 is has to be 180 degrees. Using that substitution again, just in a different way. Substitution property of equality. Then I can solve, right? We can find the measure of angle 8. And really the reason, the way you can do this is you can subtract 120 from both sides and find that the measure of angle 8 then has to be 60 degrees. And that uses the subtraction property equality. Because we could subtract 120 from both sides to get that angle measure. That is our reasoning. All right. Now we're going to start using these images here. So image 3, example 3, we have this parallelogram. So either recreate this in your notes or print it out if you have the means. But we are going to use this parallelogram here. And in this parallelogram, segments AB and CD are parallel. CD is also parallel to FG, and AC is parallel to BD. The measure of angle CDA is 20 degrees, and the measure of angle DAC is 25. We are going to find the measure of angle FGB. All right. So let's kind of unpack this a lot, right? So we have all of these pieces that are kind of just given to us. This is all stuff to know about this diagram. AB is parallel to CD. Oops. And CD, the top segment, is parallel to FG. So by transitive property, we can deduce that all three of these are parallel to each other. And then we also know that AC is perpendicular to BD. Or not perpendicular, sorry, parallel. These two are also parallel. We know the measure of angle CDA. So here is C, here is D, and here is A. So we know this is 20 degrees. And we know DAC as well. So find D, find A, find C. And that is 25. I feel like there was a type, I miswrote this somehow. But I guess not. No, I didn't. I did it how I was supposed to. Sorry, sorry myself off. So we have labeled all of the parts of our diagram, and now we want to find this angle FGB, and let's look at where that is. FGB. We want to find this angle measure. Well, I know this top line is parallel to this bottom line, right? Which is parallel to this middle line. So all three of these lines are parallel and they've been intersected by a transversal. So I have these parallel lines intersected by a transversal. So this angle FGB has to be congruent to CDB, this entire angle, by the alternate angle theorem. So that's kind of what I'm going to use to help me on this problem. The first thing I am going to note, I can note that angle DAC, and actually that's the one I was doing in green, so maybe I'll write it in green. Angle DAC is congruent to its alternate interior angle. So we still looking at these parallel lines, right? A, B, and C, D are parallel. And these two parallel lines have been intersected by this transversal. So I know then that angle CAD or DAC, however you're looking at it, which is 25 degrees, has to be congruent to ADB. So this is also 25 degrees. because they are alternate interior angles. So this means then that our measure of angle ADB is 25 degrees. Now I can find the entire measure, right? We know this angle CDB. Oh, we're not used. Maybe this CDB is going to be 20 plus 25. So the measure of angle CDB is the same thing as adding up those two smaller angles. So 20 degrees plus 25 degrees. And 20 degrees, remember that was really just angle CDA. And we're adding that on to angle ADB. So that tells us then that the measure of this angle is 55 degrees. Oops, 45. Ms. Carlson can add 45. Now I know this angle measure that I just kind of highlighted in purple here. This is 45 degrees. And remember that that angle is congruent to angle FGB because line FG and CD are two parallel lines that have been intersected by the transversal BD. All right, they've been intersected by this transversal. So angle CDB has to be congruent to angle FGB because they are alternate interior angles themselves. Which means then that our measure of angle CDB equals our measure of angle FGB. Oops. So FGB, or the measure of angle FGB, is 45 degrees. All right. I have one more example that I'm going to do in a separate video. So please watch that video when you are ready for it. But I recommend that you spend some time really looking at the materials in the OMHS and practicing problems using these properties.